So in this problem, we need to resolve the given rational fraction into partial fraction. Let's begin. Here, before proceeding, we need to check whether if the given rational fraction is a proper fraction or not. In this case, this is not a proper fraction because the degree of the numerator is exactly equals to the degree of the denominator. To check that, all we have to look for is the highest power of x in the numerator. So that's 3, and the highest power of x in the new denominator is also 3 because here we have x squared multiplied to x. Since they are the same, so what we'll have to do, we'll have to make the degree of the numerator lesser than that of the denominator. Only then it will be a proper rational fraction, and after that we can proceed. So let's do that. That means we can rewrite x cubed over, so we are going to multiply x plus 1 with x squared minus 7x plus 12. And this is going to give us x cubed minus 6x squared plus 5x plus 12. So you can clearly see here that the degree of the numerator and the denominator is exactly the same. So in order to reduce this, we have to perform a long division. So let me do it here. The long division would mean we will take x cubed and we'll have to divide it with the denominator, which is x cubed minus 6x squared plus 5x plus 12. So let's multiply with 1. So that's going to give us x cubed minus 6x squared plus 5x plus 12, which leaves us with, so x cubed and x cubed gets cancelled. Here we are subtracting, so we're going to get 6x squared minus 5x minus 12 as the denominator. So meaning we can rewrite the given rational fraction as, so we'll have the quotient here. The quotient will get added to the remainder, which is 6x squared minus 5x minus 12 divided by the denominator. So that's x cubed minus 6x squared plus 5x plus 12. Now if we look at our second term, we don't have to worry about the first term. In the second term, we can see that the degree of the numerator is now less than the degree of the denominator. That means it has been now converted into a proper rational fraction. So we are going to proceed from here, but before that let's label this as number 1. Now we can rewrite 6x squared minus 5x minus 12 divided by x cubed minus 6x squared plus 5x plus 12. So we'll factorize the denominator portion. So we'll have 6x squared minus 5x. So we will not factorize the numerator. So in the denominator, so x cubed minus 6x squared plus 5x plus 12, that was the obtained by multiplying x plus 1 with x squared minus 7x plus 12. Now x squared minus 7x plus 12 can be also factorized. So it will get factorized into the product of x minus 4 and x minus 3. So now that we have this, what we'll do, we will suppose that this is equals to the sum of 3 partial fractions because we have 3 factors here. So the first partial fraction, let's consider it to be a divided by x plus 1. Followed by the second partial fraction, we'll have b divided by the other factor, which is x minus 4. And finally, we have c divided by x minus 3. So we have 3 partial fractions. Now what we have to do, we'll have to solve this equation to obtain the value of a, b and c. So let's label this as number 2. Okay, now what we'll do, we will multiply both sides of this equation with x plus 1, x minus 4 and x minus 3. So that means we are now left with 6x squared minus 5x minus 12, which will be equals to, we're going to get x minus 4 times x minus 3 whole multiplied to a plus x plus 1 multiplied to x minus 3 whole multiplied to b. And then we have x plus 1 times x minus 4 multiplied to c. Now to find out the value of a, b and c, we're going to use a trick here. The trick means we will use 3 very specific values for x. So we are going to choose the value of x in such a manner such that the second term and the third term goes to 0, and we will be left with only the first term, which will help us calculate the value of a easily. So how do we choose the value of x? So we'll look for a factor that's common to both the second term and the third term. So here we see that x plus 1, that's common to both of them. So if we equate x plus 1 to 0, or simply x equals to negative 1, then we will get rid of the second and the third term. So let's now replace the value of x with -1 in this entire equation. So let's call it equation number 3. So equation number 3 now becomes, so we'll substitute the value of -1 with 6x squared. So we have 6 times -1 squared, which is +1. Minus 5 times -1 will be +5 minus 12. So this will be equals to, so we have -1 minus 4, so that's -5, multiplied to -1 minus 3, so that's -4, whole multiplied to a. So b and c, the second term and the third term is 0, no need to mention that. So 6 plus 5 minus 12, that's -1. -5 times -4, so that's +20 times a. So a value is -1 over 20. Now we will try to find out the value of the constant b. So here we're going to choose a very special value of x in such a manner that the first term and the third term goes to 0. For this we're going to look for a factor that's common to both of them, and here we see that's x minus 4. So if we let x equals to 4, then the first term and the third term will go to 0. Now let's substitute this value back into our equation number 3. So that means equation number 3 now becomes, so we have 6 times 4 squared. So that means 4 squared is 16, so 6 times 16 will be 96. Minus 5 times 4, so that's 20, minus 12, equals to, so the first term that goes to 0. The second term we have 4 plus 1, so that's 5, multiplied to 4 minus 3, so that's 1, so we have 5b. So let's solve this. We're going to get 96 minus 20 minus 12, so that's 64. So 64 is equals to 5b. Then means we have b value equals to 64 over 5. Now coming to the third part, we're going to choose the value of x in such a way such that the first and the second term goes to 0. And here we can see that if we take x minus 3 equals to 0 or x equals to 3, then the first term and the second term goes away. We'll be left with only the third term, which will help us calculate the value of c. Now let's substitute this value. So we have 6 times 3 squared minus 5 times 3 minus 12 equals to, then on the right hand side we have 3 plus 1 times 3 minus 4 times c. So this is going to give us 27. So 27 is equals to 3 plus 1, so that's 4, and 3 minus 4, so that gives us -1 times c. So c value, this is going to be equals to 27 over 4, and it's a negative value. Now that I have the value of a, b and c, we're going to substitute this in equation number 2. We will have in place of a, -1 divided by 20 times x plus 1 plus b. The b is 64 divided by 5 multiplied to x minus 4. And finally for c, we have -27 divided by 4 times x minus 3. So this is how we have resolved the given rational fraction into 3 partial fractions, but this is not the final answer yet. We'll have to substitute it back into our original equation 1, which is equation number 1. Thus our original equation, this now becomes, we have 1 minus 1 over 20 times x plus 1 plus 64 divided by 5 times x minus 4 minus 27 divided by 4 times x minus 3. So this is the final answer.